Hi, my name is Michael, and this is the final presentation of my GSoC project, Enhancing Creative Workflows with a Natural Language Interface for Tölvera. The vision was to create an interactive partner for artists and researchers that could translate natural language commands directly into Tölvera sketches. The aim was to lower the technical barrier to entry. While the system is still experimental, this summer's work represents a significant step in that direction. Before we dive into the technical details, let's look at a few examples of the sketches this system can create from natural language. You can create complex self-organizing behaviors between multiple species, create ecosystems where species compete for food and survival, and even simulate classical artificial life patterns, all directly from a text description. Over 12 weeks, the project underwent significant architectural switches to meet this goal. The final architecture is a multi-stage orchestrated pipeline. It starts with the user's description. The behavior analyzer then decomposes this into multiple individual systems. Next, the state manager and species manager detect and configure what the simulation needs. A key component is the context selector, a simple form of RAG, that dramatically improves reliability of systems outputs. The core of the system is the expert synthesis loop, using a targeted generation approach for generating individual expert functions that combine to form these complex patterns. Finally, the template renderer assembles everything into a complete runnable Tölvera sketch. That's the theory. Now let's walk through the full user experience. When you first launch the UI, you're greeted with the landing screen, and upon entering, the first step is to select a model. The system supports multiple providers like Gemini, Claude, and OpenAI, which are configured in an environment file. For this demo though, we'll use Gemini Flash for its inference speed. And now we're in the main interface. Let's start with the behavior involving multiple species. The prompt, two species, red and green, repel each other strongly, is already typed out, and we'll click Generate to generate the Tölvera sketch. Now let's run it and see what the system generated. The system correctly identifies the two species, assigns the colors, and synthesizes expert functions for a repulsion force. Now the real power is the iterative refinement. Let's change the color of the species. I'll add change the colors of the species to blue and orange. As I do that, the diff viewer immediately highlights the exact lines of code that were changed. This kind of transparency was a core goal of the project. Now let's adjust the physics. I'll type make the repulsion force 100 times stronger. And again, the diff view shows us the change in the generated code. Now that we have a behavior we like, we can save the sketch directly from the UI. Let's call it test sketch. And this saves the generated Python file, which can be run as a standalone sketch. And just as easily, we can load that previously saved sketch to continue working on it. This makes it easy to build a personal library of behaviors. And of course, code generation isn't always smooth. That's why we built in a self-repairing mechanism that aims to repair a failed run for a Tölvera sketch. It's important to be realistic about the system's current state. For simple behaviors, the success rate is quite high, around probably 80–90%. However, for complex ecosystems, the end-to-end success rate on the first try is really closer to 20%. As I know during development, it's still really brittle for building complex stuff, but when it works, it's quite nice. This GSoC project set out to build an intuitive natural language interface for Tölvera, and we ended with a system that, on this specific task, demonstrably outperforms general-purpose frontier models. However, it's essential to frame this as a foundational step, not as a final product. This is not the end-all be-all for this kind of interface, and the system has known limitations, especially with highly complex behaviors, and challenges like context management remain ongoing areas for improvement. What we have built is a significant step in the right direction. It highlights both the potential and the current hurdles of using LLMs for domain-specific language code generation. And most importantly, it provides a solid foundation for future work, with clear paths to improve reliability and expand capabilities. This work successfully lowers the technical barriers to artificial life simulation, and I'm very excited to see where this goes next. And thank you to my mentors Jack, Victor, and Piotr, and to the entire Tölvera community for their support throughout this entire summer. You can find the source code, documentation, and a link to the full demo video on my project blog. And thank you so much for watching.